Today's topic is testing principles. Let's start with the first question. During the project meeting, a developer argues that since the software passed all the tests, it's ready for release. As a tester, you disagree based on a fundamental testing principle. Which principle supports your disagreement? Don't jump straight to the answer. First, look at what the developer is actually saying. The software passed all the tests. Therefore, it's ready for release. That sounds reasonable until you notice the hidden assumption. The assumption is all tests pass, there cannot be any defects left. And that's the mistake. Let's check the options. Option A, defect clustering. Useful principle, but it tells us defects tend to concentrate in a small number of components. It says nothing about passing all tests. Not our answer. Option B, exhaustive testing is impossible. This is close. Since we cannot test every possible situation, passing all executed tests doesn't mean we covered everything. But notice the question. It asks which principle directly explains why passing tests does not prove the software is defect-free. There is an even better match. Option C, pesticide paradox. That's about running the same tests over and over until they stop finding new defects. Interesting, but not the issue here. Option D, testing shows the presence of defects. Exactly, testing can demonstrate that defects exist when we find them. But if we don't find any defects, that doesn't prove there are not any. Maybe we didn't test a certain combination. Maybe we missed an important scenario. Maybe the defects simply didn't appear during testing, so passing every executed test is good news. But it's never mathematical proof that the software is perfect, so correct answer is D. Exam rule. Passing all tests increases confidence. It never proves the absence of defects. Let's move on to the question number 2. Why is exhaustive testing impossible in most cases? The key words here are why and impossible. Not expensive nor difficult, impossible. Option A, blames the tester. No, even the world's best testers could not execute every possible combinations. Option C, sounds convincing because software can certainly be complex, but complexity is not the fundamental reason. Option D is another tempting distractor. Testing everything would definitely cost too much. But imagine someone gave you unlimited money and unlimited testers. Would exhaustive testing suddenly become realistic? Still no, because the number of possible inputs, sequences, configurations, environments, and users' actions is usually enormous. That's actually what option B says. This principle explains why we don't try to test everything. Instead, we choose representative test cases using techniques like equivalence partitioning, boundary value analysis, prioritization, and risk-based testing. The goal is not to test everything, so correct answer is B. And when ISTQB says exhaustive testing is impossible, think about too many possibilities, not too little time or money. Question number 3. You have been assigned as a tester to a team producing a new system incrementally. You have noticed that no changes have been made to existing regression test cases for several iterations, and no new regression defects were identified. Your manager is happy, but you are not. Which testing principle explains your skepticism? This question describes a very realistic situation. The regression suite keeps passing. No new defects are found. The manager thinks that that's great. Should you celebrate? Maybe. Or maybe your tasks have simply become predictable. Look carefully at the sentence that matters most. No changes have been made to the regression tests for several iterations. That's the clue. Option A isn't even one of the ISTQB testing principles. Easy elimination. Option C, talks about where defects are concentrated, not relevant here. Option D explains why we cannot test everything, also not the point. Option B, tests were out, exactly. If we execute the same tests against similar software release after release, eventually those tests stop discovering new kinds of defects. It doesn't mean the product suddenly become perfect. It may simply mean the tests are no longer challenging the software in new ways. That's why regression suits should evolve as product evolves. So correct answer is B. And here is the exam rule. If the same tests run forever, don't assume the software becomes perfect. Sometimes the tests become stale. Question number 4. What does the principal-defect cluster together mean? This principle is closely related to the Pareto idea. A relatively small part of the system often causes a large share of the problems. Now let's review the options. Option A says defects occur in pairs. That's simply made up. Option B says all defects are in one module. Whenever you see words like all, always, or never, slow down. Absolute words often run in ISTQB questions. Option D says defects are randomly distributed. If that were true, there would be no clustering. That leaves option C. A small number of components usually contain most of the defects. This doesn't mean we ignore the rest of the system. It means defect history helps us to decide where to spend more testing effort. Those components deserve extra attention because experience tells us they are more likely to hide additional defects. So correct answer is C. And here is the exam rule. Defects are rarely spread evenly. Past defect history is valuable input when deciding where to test more deeply. Let's move on. Question number 5. The absence of defect fallacy is one of the principles of testing. Which of the following is an example of addressing this principle in practice? This is one of the easiest principles to confuse with another one. This phrase, absence of defects, sounds very similar to testing shows the presence, not the absence of defects. But there are different ideas. The first principle is about the limit of testing. The absence of defect fallacy is about business success. Even if you remove every known defect, user may still hate the product. Maybe it solved the wrong problem. Maybe the requirements were wrong from the beginning. Maybe it doesn't meet business expectations. So what should we do? Option A says to support end user during acceptance testing. Exactly. Acceptance testing helps validate that the product actually satisfies user needs. Option B is about the refreshing test. That's the test wear out principle. Option C claims we can and should no defects remain. ISTQB never makes that promise. Option D belongs to a different testing principle entirely. It explains the limit of testing, not the absence of defect fallacy. So, option A is the best answer here. And exam rule here. A product with very few defects can still be the wrong product. Verification alone isn't enough. You also need validation. That's it for this set of questions. As I said, the main goal here was not just to collect the correct answers, but to understand the logic behind them and build a stronger testing mindset. You can find more practice questions for this topic on ISTQB.com using the link below, and if this walkthrough was useful, like and subscribe for more practical ISTQB question reviews. See you in the next one. Bye!